Amines and amides. Aliphatic amines can be made from halogen alkanes or nitrides. So if you make it from halogen alkanes, you just heat the halogen alkane with excess ammonia. So the mechanism of the reaction, this is a nucleophilic substitution reaction. You have the ammonia which acts as a nucleophile. It attacks the carbon here because this is partially positive and the bromide is partially negative. So it attacks the partially positive carbon while the bromide leaves, and that will give you the quaternary ammonium salt first. And then the next step, that we still have ammonia in the reaction mixture because we use excess ammonia. The excess ammonia here is going to act as a base, and it's going to take this hydrogen from the ammonium salt, and that will give you the product, which is the primary amine. And don't forget that you're going to have ammonium bromide as a side product as well. However, this kind of reaction will not end up with only primary amine. You're going to end up with mixture of secondary, tertiary, and quaternary ammonium ions. This is because the primary amine will still have the lone pair of electrons on the nitrogen and still going to act as a nucleophile. So it's going to attack halogen, the halogen alkane that is present here to make more of the amines, and it's going to give you secondary amine in this case. The secondary amine itself, again, is going to attack the halogen alkane, and also is going to give you tertiary amine, which is going to attack another one to give you the quaternary ammonium ion. The quaternary ammonium ion, there is no more free electrons here, no lone pair of electrons, so it cannot act as a nucleophile. So this type of reaction will end up with mixture of different amines, so the yield of this reaction is not so great. We can also make aliphatic amines from nitriles, and from nitriles this is through reduction. We can either use lithium aluminum hydride in ether and then add a dilute acid. The reaction goes in two steps. So a reduction for the nitrile group with lithium aluminum hydride first in ether, and then you add dilute acid. You're going to end up with only one product, which is the primary amine. However, this lithium aluminum hydride is too expensive to be used on a wide scale for industry. So in industry, instead, they use hydrogen gas with a metal catalyst as either platinum or nickel at high pressure and high temperature. This is called catalytic hydrogenation. So in catalytic hydrogenation, we have the nitrile. We use the hydrogen gas, use nickel catalyst or platinum catalyst at high temperature and pressure. That will also give you only the primary amine. So in this case, we only end up in these two reactions. We only end up with one product, which is the primary amine. We don't end up with mixture of different amines. So the yield here is better than the other reaction. And then we have the aromatic amines. The aromatic amines are made from nitro compound through reduction. So aromatic nitro compound can be reduced with tin and conc HCl, concentrated hydrochloric acid. If you just use the tin and hydrochloric concentrated hydrochloric acid, you will end up with the ammonium salt. So you need to add an alkali in the second step to get the amine. So you have something like nitrobenzene. This is reduction using tin with hydrochloric acid and reflux. This is the first step. And then the second step, you add an alkali like sodium hydroxide. So you end up with the phenylamine and you end up with water. Don't forget that there is going to be also sodium chloride here. Aromatic amines are very useful because they're used as a starting molecule for making dyes and pharmaceuticals. Amides are different from amines. They have the functional group C double bond O and NH2. These are one of the derivatives of carboxylic acids. The carbonyl group in the amides pulls the electrons away from the amine or from the nitrogen or from the NH2. So amides are less basic than amines and they do not act as nucleophiles. So they behave differently than different from the amines. And also we can have N-substituted amides where the hydrogen here is substituted with an alkyl group.